So on number 19, on this whole backside, we need to factor, split, then solve, right? Factor, split, then solve. We factor it to be able to get multiplication. We split it once it's set equal to 0 using the zero product property. And then obviously once we split it, it becomes two simple equations that we're able to solve. So factor, split, and solve is what we're doing on this backside. Looking at number 19, we're doing the odd ones only. It's already set equal to 0. So I know I will be able to use the zero product property if I could get something times something equals 0. And I don't have that yet. I have addition and subtraction. I need multiplication. So let's factor the left side of this equal sign. Now, you try to pull out a GCF, but there is no GCF, okay? So we're going to jump right into our steps, right? We have the steps right here. Step 1 is to multiply A times C. Step 2, make a list. If we're using the shortcut, which these are the steps to the shortcut, you set this answer format up, and then step 4, reduce each binomial. We'll do that once we get there. Step 1 is multiply A times C. So let me do a 1 right here. A times C. A is 3. C is negative 16. We get negative 48. Step 2, make a list. How could I get this answer negative 48? Well, negative 1 times 48. Negative 2 times, if you don't know what 2 times will give you 48, just get a calculator and do 48 divided by 2, and it'll give you 24. Negative 3, if you don't know, go ahead and do 48 divided by 3, and that'll give you 16. Negative 4 times 12. Negative 5 doesn't work. Negative 6 times 8 is 48, and that's about it, because 7 doesn't work. So just go through, like if you were counting 1, 2, 3, 4, and figure out what these other values are. Anyway, which pair of numbers, out of this whole list, which pair of numbers combines to give us the middle value, which happens to be the b value of 2? That's right. If I combine negative 6 plus 8, it really does give me a positive 2. So I don't have to change any signs. This is the pair of numbers that I want. So whether you're doing the original method on solving by grouping, or whether you're doing the shortcut method, the magical shortcut method, either way you have to do these first two steps, right? If you want to go factoring by grouping, that's where you change the trinomial to a polynomial by replacing the positive 2h with the minus 6h and a plus 8h. But it looks like we're all leaning towards that magical shortcut. So step 3, it says plug in that pair of numbers into this answer format, ax, ax. It's not always going to be x. Right here we have h's. So let's go for step 3, plugging it into the magical format, ax, ax, but instead of x's we have h's. Notice that our a value really is 3, so I'm going to have a 3h and 3h. Whoops, why did it change color? 3h and 3h. And what belongs right here in these blank spots? Yep, the negative 6 and the 8 go right in here, negative 6 and 8. That is step 3. Now this is totally wrong, right? This is not the right factored form. If you start multiplying 3h times 3h, it's not going to give you a 3h squared, it's going to give you a 9h squared. So this is totally wrong. And that's why I call this magic time right here on step 4, because you're not going to be factoring out anything. You're just going to look at the first binomial and ask yourself, could I divide both of these by something? And you want the greatest value that you could divide by. You could divide both of these by what? By 3. So let's divide both of those by 3. So 3h divided by 3, that's just an h. The minus 6 divided by 3, that's a minus 2. And let's do the same for this other one. Could I divide 3 and 8 by something? No, I cannot, so I'm just going to leave it. So I'm going to put a 3h plus 8. Now, ladies and gentlemen, that is just our factored form. All I've done so far is, let me get a highlighter here. All I've done is changed this quadratic trinomial. All I've done is change that quadratic trinomial to this binomial times this binomial. That's all I've done. I still have the equals 0, so I still need to write equals 0. What was the purpose of me factoring? So I could get something times something equals 0. Yes. Perfect. Now we could take this guy and split them and set them each equal to 0 using the 0 product property. So this times this gave me 0. That means that the first h minus 2, that could be equal to 0, or the 3h plus 8, that could also be equal to 0. So we have two simple equations. Let's solve those two simple equations. I'm going to add 2 here, add 2 over here. We're going to end up with h equals 2. And over here, minus 8, minus 8. We're going to have 3h equals negative 8. Final step would be to divide by 3, divide by 3. H equals negative 8/3. There you go. H equals negative 8/3 and H equals 2. Those are your two answers for number 19. Okay? It is a long process. I apologize. I hope you guys practice so it could become easier. Let's do the next odd one. So right here, it's already set equal to 0, which means that we jump right into step 1. Step 1 is to multiply A times C, where A is 8 and C is 3. So A times C, 8 times 3 is 24. That's our answer for step 1. Step 2, make a list of the multiples of that answer, 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 doesn't work, so that's about it. And then we jump right into thinking which of these pair of numbers combines together to give us the middle value, which happens to be negative 10. So if you add 1 and 24, you get 25. That's not 25. 2 and 12, that's 14. That's not 14. 3 and 8 is 11 if you add them. That's not 11. 4 and 6, that is 10. So 4 and 6 is the right numbers, but it has the wrong signs. Why do I say that? Because if I add 4 and 6, I get 10, and we want a negative 10, not a positive 10. So I have the right numbers, just the wrong signs. So let's actually switch that to a negative 4 times a negative 6. So this is the correct pair of numbers that we want, not positive 4 and 6. Now we could jump to step 3 on our shortcut, or maybe we should do a factoring by grouping. You guys want to try factoring by grouping for once, just so we don't forget? Yes? Yes, do factoring by grouping. All right, here we go. So let's rewrite. Factoring by grouping is rewrite your whole quadratic trinomial. So 8q squared, 8q squared, and instead of the negative 10q, I am going to rewrite it as negative 4q minus 6q. So let's do that. Instead of negative 10q, my b value, I want to write it as negative 4q minus 6q, and then the plus 3 is still there. Let's not forget that this is an equation set equal to 0. So I created 4 terms instead of 3 terms. Why would I want to do that? In case you wanted to practice factoring by grouping. Obviously, the shortcut's way faster, but just for funsies here, we're going by grouping. So I want to rewrite this thing and separate it into 2 groups. Notice that all I did was leave space between my first 2 terms and my second 2 terms. There's my space. Okay, so I separated the 2 groups. Then I factor whatever I can out of my first group. What's the GCF on that first group? Is it a 2? Is it 4? Is it just 4? Sounds like a bad word. 4q, that's right. Okay, 4q. And what's left on the inside? 2q and minus what? In other words, 4q times 2q gave us an 8q squared. 4q times what gets us a negative 4q? A 1, a negative 1. Now, on the other guy over here, what could I pull out? On the other group, I could pull out a 3, but notice this, guys. If I pull out a 3 on the inside, 3 times what gets me a negative 6q, a negative 2q, right? And we don't want it to be a negative 2q, we want it to be a positive 2q. So what would be better than pulling out a 3? Pulling out a negative 3. So let's pull out a negative 3, and on the inside you will have the same 2q minus 1. And now that you have that common binomial 2q minus 1, I want to put some exaggerated parentheses. I'm going to write that common binomial of 2q minus 1 on the outside, and I'm going to keep the 4q minus 3 on the inside. And this is still an equation. So because this is an equation, let's rewrite it. Let's bring down the equals 0. And we have something times something. These parentheses are horrible. They're exaggerated. But it's still equal to 0. So what I'm going to do is I'm going to separate. I'm going to say that this first something could equal 0. 2q minus 1, that could equal 0. And the second something could also equal 0. 4q minus 3 equals 0. So on the left equation, let's solve it. Man, I'm running out of space. You guys are probably really running out of space. That's plus 1 on both sides. Plus 1. We're going to have 2q equals 1. Final step would be to divide by 2, divide by 2. So q equals 1/2. That is one answer. Now let me go to the other simple equation, 4q minus 3. We're going to go plus 3, plus 3. So we're going to have, running out of space, let me zoom in. We're going to have 4q equals 3. Final step would be to divide by 4, divide by 4. So q equals 3/4. So those are your two answers for that question, 1/2 and 3/4. Q equals 1/2 and q equals 3/4. Man, that took a long time. I will probably not use factoring by grouping on the rest of this homework, right? I'm going to use a shortcut. It's way faster. So let's take a look at 23 here. Is this set equal to 0? Heck no. So what do we do before anything? That's right. Let's add that 4r to get rid of it, plus 4r. That'll get rid of it. What you do to one side, do to the other. Could you actually add 4r to anything? Absolutely. You have a negative 21 plus 4. That'll actually give you a negative 17, right? So let me rewrite what I have. I have a 10r squared minus 17r. I still have equals 6 though. And I don't want that 6. I want it to be 0. So what do? Subtract 6, subtract 6. Now I do have an equals 0 on this side. Let me rewrite everything though. I have a 10r squared minus 17r minus 6 equals 0. And now that it's equals 0, now I could actually try to factor, split, then solve. Okay, so because we have some nasty numbers here, and I can't even pull out something, there's nothing in common. You can't even pull out a 2 or a 3. So I need to just start with my steps, right? Step 1, a times c, where a is 10 and c is negative 6. So what's 10 times negative 6? Negative 60. That's our first step answer. Step 2, let's make a list. How could I get negative 60? Negative 1 times 60, negative 2 times 30, negative 3 times 20, negative 4 times, I think it's 15, but if you don't know, on your calculator, do 60 divided by 4 and you'll get the answer 15. That way you could make this list, even if you don't know all your multiplication tables, use a calculator. Negative 5 times 12, negative 6 times 10, and that's about it. Now, which pair of numbers combines together to give us negative 17? If I combine this, what does it give me? 59. How about this? 28. How about this? Okay, now when I combine negative 5 and 12, that gives me a 7. You see, you can't just change one number, right? You can't change the sign of one number. You have to change both numbers if you're going to change signs. Okay, but negative 5, this is a positive 12 though. You can't make it a negative 12. See, guys, check this out. Once you get your answer negative 60, you make a list on how to get negative 60. It has to be a negative times a positive to be a negative, right? So when you make your list, just start adding them. What's negative 1 plus 60? What's that? That's 59. What's this when you combine them? It's 28. What's this? 17, guys, 17. What do we have up here? We have a 17. That's our winner right here. I mean, it's not completely right yet, but we know that this is the right pair of numbers, because when you add negative 3 plus 20 gives us positive 17, and we want a negative 17. So all we have to do is change the signs. We have the right numbers, we just have the wrong signs. So make it a positive 3 times a negative 20. This is the correct pair of numbers for step 2. So instead of doing factoring by grouping, which takes a ridiculous amount of time, I am going to do the shortcut. The shortcut says set up your binomial format. And by the way, this is still equal to 0 once I set it up. What's my AX value in this case? 10 and R, right? Instead of AX, we're going to put 10R on both. 10R, 10R. And now what do we do with these blank spots here?
Plus 3.
That's right. The plus 3 and the minus 20 go right in there. So put the plus 3 and the minus 20. Now this is incorrect factoring, right? 10R times 10R is not 10R squared. It's 100R squared. This is wrong. So what is the fourth magical step that we need to do on our shortcut? Divide both of these by something, if possible, or divide both of these by something, if possible. So we can't do 10 and 3, right? But this second binomial, what could you do?
10.
You could divide it by 10. I mean, you could do 2, but that's not the greatest value you could divide by. So the first one's going to stay the same, right? The 10R plus 3, that's going to stay the same. The other one, when you reduce by 10, that'll actually be a single R minus 2. Now, let's not forget that the equal 0 is still there, equal 0. I have now successfully factored, right? And if I'm questioning myself, I could start distributing 10R times R. That'll give me 10R squared. So, I mean, I know it's right. This original one was not. You have to do that fourth step of dividing by whatever's possible. Anyway, we now could split and solve. We have factored. Now we could split and solve. So we have something times something equals 0. That means that the first something, 10R plus 3, that could equal 0. And the second something, R minus 2, that could equal 0. This is applying the zero product property. Let's solve both. Minus 3, minus 3. You're going to have 10R equals negative 3. How do I get rid of that 10? I divide by 10, divide by 10. R equals negative 3/10. There's your answer. Let's do the other answer. The other one's easy. Plus 2, R equals 2. Your two answers are negative 3/10 and 2. Those are your two answers. And it's still a lot of work, even though we use the shortcut method. Number 25. So on number 25, you want to get it equal to 0 first. You want to have your equation equal to 0. So let's get rid of that 7y by adding 7y to both sides. And also, you could do two steps in one. Get rid of that minus 2 by adding 2 there and adding 2 also, which you can't really add 7y or 2 to 6y squared. So you're just going to have to take all three terms, that one, and this one, and write them as a quadratic trinomial. 6y squared plus 7y plus 2 equals 0.
What if you did that way around the accent? Does it make a difference in your answer?
So once you have a quadratic trinomial set equal to 0, you can't factor out a GCF from those three terms. So let's just jump right into our steps. Step 1 is to multiply a times c, where a is 6 and c is 2. That's going to give us 12. And then step 2 is to make a list of the multiples of 12. We have 1 times 12, we have 2 times 6, we have 3 times 4, and that's about it. Which of those pairs of numbers combines together to give us the middle value b, which in this case is 7? 3 and 4 gives us 7. You don't have to change any signs. So then we move on to our step 3 on our magical steps, right? We're going to plug it into ax and ax. So let's write that, parenthesis. What is ax in this case?
6y.
6y. So you're going to put a 6y there and a 6y there. What do I do with the 3 and 4 from step 2? Plug it in. A 3 right there, a 4 right there. Step 4, this is the magical step 4. Magic time. Why magic time? Because you're going to magically divide both terms in there by whatever you can, the highest value. What am I going to divide 6 and 3 by?
3.
By 3. So when I divide 6 by 3, I only get 2y. When I divide 3 by 3, I get a plus 1. What am I going to divide both of these by?
2.
By 2. So when I divide both by 2, what do I get? 6 divided by 2 is 3 with the y. 4 divided by 2 is 2. This is our factored form. It was equal to 0. It's still equal to 0. So now that it's factored and it's set equal to 0, now I could use the zero product property to split them and solve. So I have this times this equals 0. Let's say the first something, that one could be equal to 0. And the second something, 3y plus 2, that could also be equal to 0. So we're going to solve both. Minus 1, minus 1. You're going to end up with a 2y equals negative 1. Final step would be to divide by 2, divide by 2. So y equals negative 1/2. That is one answer. The other answer, minus 2, minus 2. You're going to end up with 3y equals negative 2. Final step would be to divide by 3, divide by 3. So y equals negative 2/3. So we're solving an equation here. You want to set it equal to 0. So I would subtract 16k. Subtract 16k, which you could actually do right there. You're going to have a new 12k squared minus 1k equals, I still have 20, right? Those guys canceled, but the 20 is still there. So let me get rid of that 20 by subtracting 20, subtracting 20. I'm going to rewrite my equation. It's going to be 12k squared minus 1k minus 20 equals 0. And now that it's equal to 0, now I could go with my steps. Since there is no GCF to pull out, I want to start by doing A times C. A is 12, C is 20, or negative 20. What do I get? Calculator time. Negative 240 is what we get, and that is the answer to step 1. Step 2 is going to be long. Make a list, a long list of the multiples of getting negative 240. Now, you could go the traditional way of like negative 1 times 240 or negative 2 times 120. Or you could think about the math behind this, guys. If you're looking for two numbers that when you combine have to give you a negative 1, then it's probably going to be something like for example, if this number were a negative 56, it would be a negative 8 and a positive 7, right? If you want your middle value to be negative 1 when you combine them, those numbers have to be 1 unit apart from each other. Does that make sense? So if I go like 11 times 12, that's not going to give me 240. But maybe 13 times 14 or 15 times 16. So with the calculator, you can start guessing and checking, right? So what do we say? How about like 20 times? How about
20 times 16?
How about 20 times 21? What do we get? 15 times 16?
Positive 240.
Negative 15.
Okay, I'm sorry. 15 times 16.
No, it's negative 15 times 16.
Negative 15 times 16. Okay, the bottom line is we have 15 times 16, right? And we need one of them to be negative. But if we want our middle value to be negative 1, then you want your 16 to be negative. That way when you combine it, you will get the middle value that's negative 1. So instead of going through my long list, I just started with the calculator. You guys started with the calculator, just plugging in numbers that are consecutive with each other. So 15 times 16 gave us 240, and we decided that 16 has to be negative. So then we jump to our factored form format, AX, which in this case is 12K. 12K. We take those numbers, the plus 15, put it there, the minus 16, put it there. It's still equal to 0, but we still need to magically divide both binomials by whatever we can. 12 and 15, what could we divide those by? 3. If we divide those by 3, we're going to end up with a 4K plus 5. If we divide those by 2, we'll end up with what? 6K minus 8. Wait a minute. That means we could have divided by 4 instead of 2. So let's go back and do that. Let's divide by 4 instead of 2. So it's 3K minus 4. And it's still equal to 0. So we're going to split it. 4K plus 5 equals 0. 3K minus 4 equals 0. Solve it by subtracting 5, subtracting 5. You're going to end up with 4K equals negative 5. Final step will be to divide by 4, divide by 4. So our answer is k equals negative 5 over 4. That's one answer. The other answer, we need to add 4 there, add 4 there. We're going to have 3k equals 4. Divide by 3, divide by 3. So k equals 4 over 3. So those are your two answers, negative 5/4 and positive 4/3. And the last question, number 29, if you want to see that one explained, go back and watch the previous video on the lesson, on the opener. We did this question on that previous video.